This is the video for 3.1 exponential functions. We're going to start off with an exponential that has a base of a number, and we're going to start with a basic one of 2. So we're going to make ourselves a table, and I would suggest you always start with this table for exponentials. And for your x values, I want to start with -1, 0, and 1. Those are going to be the easiest values for you to do. So if I do 2 to the -1 power, that's a half. 2 to the 0 power is 1. 2 to the first power is 2. So if you notice when you go to graph these, that whatever this base number is right here, this is going to be 1 over that number, 1, and that number. So if this was a 6, this would be 1, 6, 1, 6. If it's a 9, it would be 1/9, 1, 9. So it ends up being, so anything to the x is going to be 1 over a, 1a. So that's just a generalization for all of our exponentials. And then that will help us later on when we go to find everything else. So I'm going to plot my points: -1, 1/2, 0, 1, 1, 2. Oops. And try to connect them the best I can. And I also have an asymptote. Let me make this a little thicker so you see the asymptote. A horizontal asymptote. So my y-intercept is going to be 0, 1 for my parent. I haven't moved anything. My asymptote is y equals 0. It's a horizontal line. This is increasing everywhere. So as you look at this equation, my graph is getting larger everywhere I go. That's a really bad line. So I'm increasing from -infinity to infinity. Ooh, that's really ugly. Okay. I also want to talk about your end behavior. So my limit as x approaches infinity of f of x, and then we're going to talk about my limit as x approaches -infinity of f of x. Here's my pen went. Okay, so as I'm approaching positive infinity, I want to do this one, my graph is going up, and so it's going towards positive infinity. This one will be a little bit newer because most of the time in the last unit we did them all to positive infinity, negative infinity, or if you had asymptotes, they went towards the asymptote. So this one is going to get closer and closer and closer and closer to 0, but it's not going to cross this particular line. The exponential functions won't cross it. Only the rational functions can possibly cross it. These are just going to get closer to 0, but not cross it, so my limit is 0. So you'll notice when you do your exponential functions, one of them is going to be some form of infinity, positive infinity or negative infinity. One of them is going to be 0. And it could be switched depending on whether I'm doing a log or an exponential. My domain is -infinity to positive infinity. My range doesn't include 0, is 0 to infinity. And that is my basic exponential graph. Oh, and I forgot to mention that this is exponential growth. Because as your x's are getting larger, so are your y's. Okay. On this next one, you'll notice that our parent function is 5 to the x, and we have a negative on it. So our parent function is 5 to the x. And if you remember from Algebra 2, oh, that's a bad one. So let me make this skinnier and note it. This negative right here means that it's going to be a horizontal reflection. So we're going to do the parent first. Let me make the pen a little thicker. My -1, 0, 1. And so since my parent function is 5 to the x, we're going to do 1/5, 1, 5. I'm going to draw in my parent first, and then I will take care of the horizontal reflection. So my parent I'll do in red. That's the one that's this color. So that's 1/5, 1, 5. However, my horizontal reflection, which takes into account the negative, I'm going to flip it horizontally. So now it'll be at -1, 5. The 0, 1 still stays the same. And the -1, 1/5 becomes +1, 1/5. So it flips it horizontally, which makes this decay, exponential decay. So now let's go through and do all of our domains, ranges, and everything for that. So my domain, oops, before I do that, let me go back, draw in my asymptote. Now I'll do my domain. It's still the same as it was when it was an exponential growth. My range is still 0 to infinity. Okay. My y-intercept, in this case, is still 0, 1. I haven't moved it left, right, up, or down. All I have done is flip it horizontally. But this time, this is decreasing on -infinity to infinity. Then my end behavior, my limit as x approaches -infinity of f of x, my limit as x approaches +infinity of f of x. So for that, for my -infinity, I'm doing my left end behavior. This is pointing up, so it should be positive infinity. And then my right end behavior, where I'm approaching +infinity, this is getting closer and closer and closer to 0, so that is going to be 0. The other thing that I have to do is write the equation of my asymptote. Again, this is the same. This is y equals 0. Okay. Many of the problems that occur in nature require the use of an exponential function whose base is a certain irrational number symbolized by the letter e. So mathematically, your number e is defined as your limit as x approaches infinity of 1 plus 1 over x to the x. And if you remember from Algebra 2, this kind of looks similar to your compound interest formula. And as we get to sequences and series later in the year, we also will talk about e. The main thing you need to remember is that e is approximately 2.7. Okay, next we're going to graph e to the x. So our parent function for e to the x, we're still doing -1, 0, and 1. And I said on the other screen that e to the first, and I'm going to kind of do this one backwards, is 2.7. E to the 0, anything to the 0 power is 1. And this you're just going to have to memorize. E to the -1 just means 1 over 2.7, which is about 0.37. This chart you're just going to need to memorize. Plus, when you get to calculus, you're going to need to know a lot about e as well. So we've got -1.37, 0, 1, 2.7. Let's connect these the best we can. And again, it's still an exponential. It's just a special form. Asymptote is still in the same place. This, you'll notice when it's e to the x, is growth, exponential growth. And so, again, my domain is -infinity to infinity. That's an ugly infinity. My range is 0 to infinity. This is increasing everywhere. And then, again, my end behavior, my limit as x approaches infinity. And then I want my limit as x approaches -infinity. So my limit as x approaches infinity means that I'm looking for it going to the right, so this is going towards positive infinity. And then my limit as x approaches negative infinity is on the left. This number is getting, let me draw this a little better. This is getting closer and closer and closer to 0. So my limit is 0. I don't think I need, oh, equation of asymptote. The asymptote is horizontal. That's y equals 0. Okay. Now we're going to try e to the negative x, just like we did with the 5 to the x. We're still going to use our parent table, -1, 0, 1. My suggestion would always be draw in your parent first, and then do all your transformations. That's the easiest way to do them. However, this negative up here, oops, I meant to do that in green. The negative up here is a horizontal reflection. So all I need to do is reflect these values horizontally. It's hard to do with this small pen. Let me make this fatter pen. And this will be my graph. Asymptote in the same place. Okay. So my y-intercept, I can get from the picture, is 0, 1. My asymptote, still horizontal, y equals 0. My domain, still all reals. The only time your domain and range are going to change is if you start moving it around. My range is 0 to infinity, same as the other slides. Your end behavior, your limit as x approaches infinity. Your limit as x approaches negative infinity. So if I want to approach positive infinity, that means I'm looking at the right-hand side. This number is getting closer and closer and closer and closer to 0. My left end behavior, which is negative infinity, is pointing up. So this is getting closer and closer and closer to infinity. Ooh, that was really bad. Infinity. And this is decreasing everywhere. So negative infinity to infinity.